So good afternoon and welcome to today's webinar. My name is Matthew McKnight. I'm a technical specialist at Autodesk. I work out of one of our Melbourne offices, and today we're covering a very popular topic, and that is large assembly management with Autodesk Inventor. Now this is part one of what has become a two-part webinar, understanding that this is quite a lengthy topic in preparing the material. I decided to bring this or break this up into two sections, looking at various different aspects. So rather than trying to push through the content as quickly as possible and cut out what might be critical to certain users, I've decided to break this up and have a very comprehensive look at, a lot of the variables that can impact your large assembly management with Inventor. If we look at the agenda for today, we'll be looking at a range of things. We'll, understand a little bit about what are large assemblies. We'll cover some of the terms and considerations, some common practices and their pitfalls. We'll look at how you can plan projects and work with file management. We'll then work inside of Inventor, set up some preferences and look at settings and the impact that they'll have on your designs, as well as visualization effects and graphics. We'll then move on to look a little bit about express mode before finishing off on large assembly modeling workflows. So even in today's content, you're going to see a lot of information. Part two, which is held in a couple of weeks' time, will cover content around using selection filters inside your assemblies, how you can manage component count, how you can simplify your components, additional practices that you can employ, representations. Also cover system hardware and how that impacts your large assemblies, how you can increase your system memory and your capacity for working with large assemblies. We'll then move through and work on a practical example of working with a large assembly, and then any additional information that's necessary. So you can see there's going to be a lot of material covered across these two sessions. But let's get stuck straight into it and look at what are large assemblies. Now, don't be confused here with the definition, because many of you might attribute that to simply a part count. You might say, well, I've got 100,000 parts in my assemblies and 10,000 of which are unique. But that doesn't necessarily mean it's a large assembly. By all means, that is a large assembly. But the reality is that it alone doesn't mean that it's a large assembly. The reality is that it's more typical as well for an assembly of, say, 3,000 to 5,000 parts, 1,000 to 2,000 which are unique, to also be considered a large assembly. And that really does come down to a number of variables. In this case, it could be the complexity of the individual components inside that assembly that defines it as being a large assembly. So more commonly, we would refer to a large assembly as any assembly file that adversely affects the performance of your system or your experience. Now, what are some of the telltale signs that you're working in a large assembly? Well, as your designs become larger and much more complex, they can go on to then consume more computing resources, and this often leads to, some of these are the telltale signs, longer than expected load times. You might be expecting error messages associated with memory, or either low or out of memory. You might be experiencing poor graphics performance. You might be having difficulty creating drawings. Even opening drawings can take a while. So these are just some of the telltale signs associated with that. The reality is that the causes for these could be quite complex, and it may not necessarily be one. It might be a combination of various different factors that actually contribute towards the performance or lack of it. So it could come down to the overall component count. It could be the number of unique files. It could be the complexity of the geometry. It could be just the way that you're using things like level of detail inside of your drawings. It also could be hardware related. It could be maybe memory related or hard drive related. It could be the processor speed that you're using on your machine. It could be even graphics card. There is a lot of reasons that it could be, and hopefully through the course of this topic we can cover a lot of this information to help improve the performance of your large assemblies. Let's look at large assembly terms and considerations, just some of the more common ones. Occurrence is a reference to a part or subassembly from the main assembly. So as you can see in the image on the right there, if you have a pattern or numerous instances of a part or a subassembly inside of your assembly, you'll note that this becomes an occurrence. It's unique once, but it's actually attributing to the overall number of occurrences within inside of an assembly. Here you can see 4. Now, performance is the speed at which a task can be completed. The lower the time, the better performing your systems. The longer the time, the poorer the performance. Often this is seen in things like opening files or creating a drawing view or rendering an image from your system. Capacity is another term that's often used, and this is the amount of memory required to perform an operation, and the capacity affects the number of components you can effectively use in an assembly. So the higher capacity system you have, the higher threshold you have in terms of being able to work with large assemblies. And lastly, express mode, and this is a method that's used inside of Inventor that helps you work with large assemblies and can help significantly reduce the time it takes to open your models. The good thing is that Express Mode optimizes for performance by loading only the model display and relevant top-level data that's necessary for you to use, and then any other information that it's required, it will actually load on demand. And before we go into some of the intricacies of the various different aspects that can impact your performance, let's have a look at some of the more common practices that users use that can impact the large assembly performance of their systems. Firstly, the practice of actually using using more than one level of display representation inside of a drawing. The impact of doing this means that for every view using a different level of detail means that a copy of that assembly is loaded into memory. So across a multi-sheet drawing, you might have 2 or 3 level of LODs being used, and what's in essence happening is in the background to manage this, the system is actually loading 2 or 3 different instances of that assembly into memory. How can you avoid this happening? Well, you can use view representations instead of LODs. By doing this, you're actually reducing the overall demand on your system to be able to load information in the background, whilst at the same time getting a similar or the same result. What about the overuse of adaptivity? Now this can lead to problems because the part geometry must be updated along with the assembly constraints, and this really impacts you because all of the parts essentially are being recomputed. So a best practice for this is to use adaptivity discretely. If you need to use it, avoid using cascading adaptive relationships where you've got, say, part 1 which is being derived from part 2 and then part 2 is being derived from part 3. Also consider using skeletal modeling in place of this, and we'll talk a little bit about skeletal modeling later on. But also consider turning off adaptivity until the model updates occur. So if you do actually need to use it, then turn it off when you don't actually need to use it. Another common issue is an under-constrained subassembly. In this case, we use the example of a hydraulic or pneumatic cylinder that's got the ability to be able to extend. The challenge associated with this is that because it's a flexible subassembly, it exposes all of those degrees of freedom inside of that assembly, and it adds additional resource requirement on the system to be able to manage that. A best practice for avoiding the challenges associated with is to ground that subassembly. So where possible, try and avoid having all these flexible subassemblies contained inside of your assemblies. Now, sometimes you might experience this where you have low system memory. Often or sometimes you might encounter a low memory warning or an out of memory warning error if it goes beyond this. This is because Inventor is, in essence, it's loading this information into RAM, and once it exceeds the storage capacity of RAM, it then starts transferring this information to a local hard drive or a swap space. In doing so, this can significantly slow down Inventor's performance, because the performance of writing information to a hard drive or a hard disk can be inferior, and in many cases significantly inferior, than writing and reading that same information from RAM. The obvious way of resolving this is to simply increase your system memory. The alternative is to reduce how much memory you're actually using, either inside of Inventor or through other background programs that might be stopping you from using the available RAM that you have inside your system. And we'll talk a little bit about that later. Another common issue is where you use derived parts in drawing views, and so we've seen instances where some people have resorted to using a derive on large assemblies before creating views, and this is to simplify that assembly down for the drawing. The problem associated with this is the entire model is calculated for creating the view, and this has a negative impact on the performance. So best practice here is to actually avoid using derive or shrink wrap models with detailed drawing views. So if you are using this methodology and you're encountering poor performance, potentially it's because of the fact that you're using these derived parts inside of your drawing views. Another common one, and I myself have experienced this at various times, is through using complex sketch patterns or complex feature patterns that actually add to the requirement of your system resources. So features like threads or pattern cutouts can significantly impact your performance. The way of avoiding this is to actually use appearances or textures to replace the pattern. Now, a common one that I've seen used in industry is you've got, say, a grating on a platform, and someone has gone and cut out all of the holes inside of the plating, or they've patterned all of the bars that go into that plating. Reality is it may be going to significantly improve your performance by removing all of those pattern features or cutouts and simply replacing them with a texture. And in many cases, the texture will actually show holes through the part, so you get a similar effect for what you're looking for. The challenge is the part mass doesn't necessarily weigh the same as what it would if you did have all those cutouts in place or the correct geometry. Reality is you can go and override that with an eye property anyway, so that negates that problem in this instance. Another interesting practice is leaving the contact solver running after using it. So it's not uncommon for people to use the contact solver when they're running a dynamic analysis to look for contact inside of their assemblies. But doing so can affect the performance. So if you're not using it, turn it off. And that's really about it. Develop the habit of actually turning off the contact solver when you're not actually using it inside of your assemblies. What about the project planning and file management? So this is a new section that will start looking at the structure of your files and the way that you're managing the information, either before you're doing that or whilst doing it. Now, there's a lot of information out there about how you manage files, in particular in other applications. Might be using a generic window application. In many respects, the best way to manage files in a Windows system is using a flat folder structure, and the reason for this is because this is essentially the easiest way for the software to be able to find or engage with that information. The challenge is when you've got say a 10,000 part assembly, to contain all of that information inside of one folder is unreasonable or impractical. The reality is that you're going to need to use subfolders, but what you want to do is get in the habit of not going overboard. So we don't want to have all of our files inside of one folder. We don't want to have hundreds of folders with very few components in them. A rule of thumb that I've seen thrown around is to try and make your directory structure as flat as possible, but to also avoid folders containing more than 800 files. So that gives you a bit of an idea on maybe a threshold of once you start to get to around 800 files, then maybe you're starting to reach the limitation of managing all that information inside of one folder. Also, top-level assemblies should appear in the same folder where the project file is located. And then put all of your parts and sub-assemblies inside of subfolders inside of those directories. Some recommendations when it comes to planning for assembly hierarchy efficiency. Create a shared network directory where components can be located and used by designers across various different projects. Create a unique template that can be used for a specific project or subassembly. And inside of that template, you can even assign common properties so that any components or assemblies or drawings that are created from that can automatically inherit the properties from that template. You can use search attributes both inside and outside of Autodesk Inventor to help you find needed component files. And you can also name or save and name those attribute searches as well. When it comes to project files and libraries, there's a number of things that you can do to try and help improve your performance. Firstly, set the included file path option to point to a single read-only project file that's maintained on the network by the CAD administrator. So really what we're trying to do here is make sure that all of the users have got access to that common project file, which is being managed by a CAD administrator and is pointing all of the users to the appropriate locations of any other information they're using inside that project. Never locate a workspace on a network location. Not only have I bolded this, but I've underlined it. One of the most common challenges I've seen when it comes to large assembly performance is people trying to open large assemblies across a network location. The simple fact is that working on your files from a local directory is going to offer you significant or potentially significant performance enhancement. And it's part of the reason why we also recommend customers to use Vault as part of that workflow, because Vault will automatically copy your files, the ones that you need, from a network location to your local drive. So you're working locally, you're making changes to from your local hardware, and then transferring that information back and managing the rights associated with that across a multi-user workspace. The other thing you can do is to try to never define workgroup or library locations that point to subfolders of the workspace of another workgroup or library. So what we're trying to do is try to avoid where you're intermingling workgroups and libraries across various other workgroups and libraries. Some further tips for handling project files and libraries. Map network drives will slow down the machine's ability to open and save files, because Windows in essence is attempting to resolve these every time that you open and save. Make sure that you keep relative paths set as true. The fewer workgroup search paths defined, the better. So make your assembly the structure as flat as possible, and we talked about this a little earlier. But also, if your projects require portability, as in you need to be able to move that project around, define all storage locations as subfolders of a project folder. So in essence, what we're saying is if you've got all of the library components, all of the stock components, all of your sub-assemblies, all of that information should be contained in subfolders of a project folder where the project file is actually located. And finally, a quick word on using custom Content Center or the Content Center library in general. Now, the Content Center is great because it's a database with over 750,000 parts of, roughly 18 international standards. The challenge is that your first thought when you see this is to turn all of these different libraries on so that you've got access to them whenever you need them. The reality is that you're going to get a performance boost by only loading the necessary libraries that you're using. Actually, if we were to go one step further, consider copying the families within inside of a specific library to a custom library that you use, because by turning on a library, you're actually loading up all of the families within inside of that library. By just having a custom library with, say, the specific fasteners that you use or bearings, then only that information is in your project file when you load it up. Okay, preferences and settings. Now, we'll spend the next little bit looking over the ways that you can change some of these to improve your performance. You can access this by going to File, Options, and the Application Options dialog box opens with almost, about 15 different tabs located across the top of it, with potentially hundreds of different settings that can be adjusted, all of which will have, or many of which will have, an impact on your performance. So let's look at some of the more common ones to help you improve your productivity. Firstly, if we go to the General tab, here we want to make a couple of changes if they're not already set by default. We want to make sure that Show Command Prompting is switched off or deselected. When deselected, this turns off command prompts displayed in a tooltip near your cursor. So it's just going to save the system memory a little bit in presenting that information to you. Because we're working on larger assemblies, we want to make sure the undo file size is increased in size. Now, I've increased the file size to 8,191 megabytes, which is the maximum allowable. So this is going to give us some headroom, because we're working on larger files, to track and manage a lot of the undo options that we have. The other option that we're changing here is the Enable Optimized Selection. We're making sure that that is checked. This is going to improve your graphics performance when it comes to pre-highlighting in a large assembly. If we then switch to the File tab, we want to make sure that Associative is just looking at the image, a reminder here, I had to remind myself, it's not actually on the File tab. Is a sub-dialog box that if you go down to File Open Options and click on Options, it opens up the File Open Options area. And within inside of here, we want to make sure that Associative is checked. And this controls the associativity with the design view representation in the model file that you're working with. And we want to make sure that from the pull-down box that last active is selected, and this loads the design view representation that was last saved with the assembly file. From the Colors tab, we want to make one change if it's not already set by default, and that is making sure that Enable Pre-Highlight is deselected or off. When turned off, pre-highlighting does not show during component or part selection priority. On the Display tab, we want to make a few changes here. We want to set the view transition time to 0. By default, it's probably set around 1 or 2 seconds. This controls the amount of time that it takes to transition between views. So if you're switching to an isometric view, or you're going zoom all or zoom area or view face, it will slowly or gradually transition between your existing position to that new position you want to move to. And by changing this to off, it will actually snap essentially the view into that orientation with no delay. So again, it's really only saving you a few seconds to do so each time, or potentially a second or two each time to do so, but over time all of these sorts of things will add up. The minimum frame rate setting in Hertz, we're setting this to 10. This specifies how fast to update the display during interactive viewing operations like rotate, pan and zoom. By using 10 here, we're setting it for a balance between visual fidelity and performance. Now, just slightly below that, there's two settings we also want to change, and that is display quality. We want to make sure that's set to rough, and this sets the resolution for the display of the model. And we also want to make sure that disable automatic refinement is set to on. Now, turning on refinement will enable coarse faceting, which can increase performance, in particular when working with large assemblies or complex models. Now, towards the bottom there on the left, we want to make sure that we turn off both Show Origin 3D Indicator and Show Origin XYZ labels. This, in essence, adjusts the display of the XYZ axis indicator in the bottom left corner of the graphics window. So not only does it turn off those, it also turns off the XYZ labels associated with them. So we'll turn those off. Moving to the hardware tab, there's only really one change that we need to make if it's not already set by default. We want to make sure that performance is the state that we have our graphics setting set to. In essence, this is going to set a couple of things in the background. It's going to turn anti-aliasing off, which will help improve our graphic performance, but it's also turning graphics multi-threading on and graphics performance optimization on. Now, a little later I'll show you as well, some of the other settings, the impact that they have. But in this instance, for performance on large assemblies, it's best to have the performance options set to on. On the drawing tab, again, a number of changes we want to make here if they're not already this way. We want to make sure that retrieve all model dimensions on view placement is unchecked. By clearing the checkbox, the dimensions will be manually retrieved after the view is placed. Display line weights is unchecked. By unchecking this, the lines will be shown on your drawings without weight differences. This doesn't impact the printing of those. It only changes the visual representation shown whilst working inside of Inventor. Show preview as, we're going to make sure that that is set to bounding box. So this sets the preference for the preview images on your views. By defining this, it doesn't have any effect on the resulting drawing view, it's just on the preview associated with generating the view. And then we'll also set the section view preview as uncut, and make sure that's unchecked. It's checked. Getting a little bit confused with uncut and unchecked. But make sure that that box there is checked, and this controls the section preview and whether it's actually showing or not. So by selecting the checkbox, this means that the model is uncut. Now this doesn't have any effect on the actual resulting drawing view, it's only on the preview that's generated during the section view creation. And finally, enable background updates equals check. Now we've switched by doing this switches the display of raster drawing views on or off. Now, raster views in this instance is going to help us increase the productivity when we're working with drawings of large assemblies, and that's the reason for turning this on. Moving to the notebook tab, and now this is associated with creation and attachment of notebooks to certain features and parts within inside of your design. By turning this off, this note icons off, this clears the this removes the icon which actually shows that there's a notebook attached, and this is again just going to save us some resources when we're working on our assemblies. Moving through to sketch, we'll make sure in this instance that we have auto project edges for sketch creation and edit, and that's unchecked. By clearing this checkbox, we basically suppress the automatic creation of reference geometry when we enter a sketch. You've often encountered that where you'll select a face, you move into a sketch, and it automatically creates the reference geometry. This will stop that from actually taking place. Assembly tab, Again, a few changes to make here. We want to make sure that the Defer Update is checked by selecting this, the Defer Updates of an Assembly. We defer updates of an assembly until that you click on the Update icon for the assembly file. So essentially this means if you make a change to a part, you move then back into the assembly that that part is contained within. An update won't then flow onto that assembly and then downstream to any other parts until such stages as you actually hit the update icon for the assembly. Enable relationship redundancy analysis is unchecked, and when this is cleared, Inventor skips a secondary analysis which normally checks for redundant relationships and analyzes all component degrees of freedom. So it's, in essence, it's just avoiding doing that. Enable express mode workflows. We want to make sure that this is checked. And this turns on the express mode capabilities, but it also starts to save enhanced display and model data with inside of the assembly file each time we open and save that file, and a little bit more information on that later on. Open Express when referenced unique files exceeds, and we're setting this to 500, which is the default when you do turn this on. And you can adjust this up and down depending upon the size of your assemblies and the uniqueness of them and in terms of their complexity. But in essence, this is setting the threshold used to determine when the default mode for opening assembly should be either express or opening it in full. Now finally, a couple of other bits and pieces. In reference to defer updates, you can also defer updates when you open a drawing. In this case here, we're opening the drawing, and from the pull-down box at the bottom of the screen here, we can actually defer those updates. So if we've been working on an assembly but we want to quickly check something on a drawing, we can open that drawing, deferring all the updates, and even once we're inside of that assembly, then we can update the drawing by simply hitting the update icon, which will then go through and regenerate all of the drawing views and the information contained within. You can also, within side of the, when you've got a drawing open, you can go to Tools, Document Settings, and on the Drawings tab of that Document Settings, you'll find Defer Updates as well. You can check this here as well, which will automatically so we'll turn off all automatic updates of drawing views and mean that that is a manual process as well. And likewise, you can actually click the top node of a drawing, right-click it, and then go down to Defer Updates as well. So here's another way of accessing the ability to be able to defer your updates with inside of a drawing. Now for document templates, there's a couple of tips here. One, inside of that same location that we just saw, so inside of the document settings with inside of an open drawing, we can go to the drawing tab and under the area use bitmap. Recommendation is to set this to always, and this sets the frequency for using bitmaps on shaded views to always. And this ensures that we're managing the resources in generating those shaded views by using bitmap images. Another tip here is to, if you've got a template that's using images placed within inside of that template, is to actually cut down on the file size that may be used. It's all too common to actually grab a really high definition image or logo, put that into your template, scale it down, and use that on every drawing that you create. The reality is that by generating that image in the background often requires additional resources to be able to do so. So what you can do is look to reduce the color of that, the number of colors. Maybe you can reduce that down to 8-bit or even 8 colors if possible, or preferably just go down to monochrome, and that's what I've done here with the Autodesk logo. Maybe you can replace that just with a monochrome representation, which significantly reduces the size of or the amount of resources that's required to generate that each and every time you're working with an assembly file, a drawing file. Some other things that you can do is unload unnecessary add-ins. Now, we had an earlier, I spoke earlier about memory each time you load Inventor, it is likely going to be loading a whole bunch of different add-ins in the background, some of which you may not necessarily be using on a regular basis. In this instance, I've highlighted Nastran InCAD, but there might be other areas, the factory layout. Maybe you don't use Frame Generator. Maybe you're not interested in Materials Advisor. There's a whole bunch of functionality in there that if you are hitting a limit in your system to be able to work with large assemblies, then potentially you could capture back some of your system resources by unloading and turning off the automatic loading of add-ins inside of Inventor. Now, the reality is this is going to reduce the time that it takes for Inventor to load, reduces the memory footprint, but the reality is we also we don't want to recommend that everyone does this. This is not a solution to anything other than to try and help you with large assembly performance if you're already suffering. What our preference is or recommendation is that you don't unload these Autodesk add-ins and that you do actually retain the automatic loading of those unless you're getting large performance issues. Unload unnecessary add-ins. There's a couple of ways that you can do this. You can do it from the Start menu. So if you go to Start All Programs, you look for your Autodesk folder, and inside of there should be a program called Add-in Manager. In my instance, it's the 2018 release. You can open that up, and that will give you a dialog box where you can turn on or off the add-ins that you don't want to load inside of Inventor. Likewise, you can do this with inside of Inventor. So if you're in an active session, you go to your Environments tab, Add-ins, and that will open the same dialog box. Recognize that if you are unloading and you want to turn off automatic loading of those add-ins, you will need to restart your Inventor session for those changes to take effect. What about visualization effects and graphics? Well, there's a few things here. Inventor has got some really strong visualization effects that are actually running in the background, even in just day-to-day use of working with inside of Inventor. It's quite impressive. But some of these can actually have quite a drastic impact on the performance of working with large assemblies. And you can see some of those which are shown on this image here, things like anti-aliasing and lighting and reflections inside of the background and likewise. Now, one of the best ways of defining the way that your graphics system is going to run inside of Inventor is to use one of the predefined settings from your Application Options Hardware tab, which we highlighted a little bit earlier. And if you select this, you'll find that you can choose a range of different areas, options, quality, performance, and conservative. Now, before we recommended using performance. Inside of this area, you can also choose to select the diagnostics area as well, which will give you some feedback on your system and information related to the driver that you're using and what version of. If we look at this, you'll see here gives a good representation of what these options are actually changing in the background. So if you go for quality, you've basically got everything on. You're wanting the best visual quality that you can with inside of Inventor. If you're going conservative, then you're effectively switching all of that off, in which case you're running the graphics mode in its most stable form, and if you're encountering stability issues, then I would definitely recommend that you use this mode over the other two options. But if you're working with large assemblies and you're not having stability issues, then likely the best option for you to choose is the performance option, which is going to turn anti-aliasing off, graphics multi-threading on, and graphics performance optimization on. So it's a balance between giving you good quality but also giving you performance with large assemblies. Now, like I said, from the Application Options Hardware tab, you can run a Diagnostics Check as well on your system. and by clicking on that, that'll bring up a report that shows what your graphics driver is, what the file is associated with the graphics driver, what mode you're running in, all of the information that potentially can help you try and help understand any challenges that you might be having in this area. And also, if you're dealing with support staff from Autodesk or a reseller, this is information that could definitely help problem solve issues that you're having with stability of your system. Okay, now we spoke a little bit about Express Mode earlier on, and we're going to go into a little bit more depth as to what it is. Now, working with large assemblies, Express Mode helps you open models much faster by loading only the component cached graphics into memory. Express Mode is an option that you need to enable, and we spoke of and showed you how you can enable that using your system options earlier. But whereas Load Full loads all of the component data and all of the commands into your system, by loading Express, you're only loading a subset. You're only loading cached graphics, and you're also excluding some commands from your workspace by doing this. Now, in many cases, loading Express can provide significantly faster, and in this instance, we're talking around maybe 3 to 5 times improvement in performance when it comes to opening a large assembly. Express Mode causes enhanced display data or cached graphics to be saved in an assembly file. So what you will notice is this, and I think I'll highlight this later on in the presentation, is that by turning on Express Mode, they're actually gathering the information that they need or Inventor needs to be able to run in Express Mode and saving that within inside the assembly file. So this extra information is actually going to mean that your file sizes are going to increase, but it's going to potentially significantly reduce the time taken to load and work with your large assemblies. The good thing is that as components are accessed or you need to perform tasks on them, they're then fully loaded into memory. What you'll realize in using this workflow is over time, as you load components, you're working with inside of sub-assemblies and components with inside of sub-assemblies, that gradually the performance may degrade because you're essentially converting an express sub-assembly or component into a fully loaded one. But the good thing is that you can simply save the assembly and then reopen it, which will then reopen everything in Express Mode again. How can you do this? Now, this comes back to a workflow that we showed a little bit earlier of going inside of your application options to the assembly tab and then down towards the bottom of the screen there, and I'll bring in an illustration that shows a little bit closer. You have the Express Mode settings area. Here, by turning on Enable Express Mode Workflows, this saves, in essence, any file that you then open thereafter is going to have this Express Mode data saved within inside of that file, and you will see changes to the file sizes. And likewise, we've seen before that you can turn on the File Open options, where you select Open Express when referenced unique file exceeds. This is going to set the threshold by which Express Mode will actually be triggered. So any components that are any assemblies that have either 500 or more unique components in this instance would actually open up in Express Mode. Now, like I said before, this information is contained within inside of the assembly or the sub-assemblies or the components. So you're going to potentially see an increase in the file size. By opening and then simply saving the file, then that adds this unique information to that file. And I did this a little earlier to understand the impact, and I had an assembly which prior to opening in Express Mode or opening and saving that file with Express Mode turned on was around 1.1 megabytes. It went up to 4.2 megabytes after. So you will see an increase associated with that change. How can you enter express mode? There's a couple of ways. You can have it triggered, as we saw before, so it'll automatically happen for you when it recognises that maybe 500 or more files, or 200 or more, whatever you want to set that threshold at. But you can also, when you go to open an assembly from the dialog box, you can change either or select either full or express from the pull-down box contained at the bottom of it. But you can also, within sort of the home screen, you can select on the file open options the ability to be able to open full or express as well. So there's a number of places that you can actually set this if it's not automatically being triggered for you in the background. And like I said before, there's a number of commands that aren't available when working with inside of express mode. But the good thing is when you convert those sub-assemblies and components to full, you will get access to the features that are required. So, limitations exist in being able to place components, add constraints and joints, right through to section views and copy mirror components and representations. So there's a number of areas that may be impacted by this, but like I said, the ability for the system to be able to manage a lot of this is automatically is great. And you've also got the ability to be able to load full, which is accessible, as you can see on the screen, from the assembly tab, and across to the right you'll see the ability to be able to load full any assembly that you're working on, or sub-assembly or part. So finally, let's move into large assembly modeling workflows, and there's a number of ways that we can work with our data when we're working with large assemblies. Now, one of the more common ways is bottom-up, and it is a more traditional way of building assemblies, the way that I was taught many years ago to design as almost sort of the default construction methodology. So it's no surprise that many of you may already be using this. The challenge associated with this is that it consumes a lot of system resources in doing so, and can significantly slow down your overall system performance. And changes made to a system often ripple up through the design. So, if we look at the bottom up, we're essentially forming all of these parts, and then all of the parts are constrained together inside of a sub-assembly, and that sub-assembly is put maybe into another sub-assembly, and then that one's put into another one. Because of this construction methodology, there is a lot of dependence between the system. Essentially everything has a dependence on various other aspects of the design. Now, top-down is the opposing method, where we start by defining the end result and build in all of the known design criteria into essentially the top of our design. In this way, it can help you to create a single conceptual file, which is great, because if you need to make a change to your design, then you can do so by making a change from one area rather than across multiple different locations. So let's have a look at some of these top-down design methodologies, and one of them is using skeletal design methods. And this is a form of top-down design and is often used when working with large assemblies. It can sometimes often provide a more stable Inventor model. It promotes faster updates. It can provide more available resources when working with larger data sets. And it also, in some cases, can provide an easier way when working in a collaborative environment. So if you've got multiple team members working on a common design, then having all of those people working on a skeletal model can, in many respects, be simpler than having them working on various different aspects of the design. Now, there's actually, when it comes to skeletal modeling, there's actually 2 or 3 different variants of this. So we'll look at a few of those. Firstly, single part or single level process when it comes to skeletal model. This is where we use a master part, which is inserted into our top level assembly, and then becomes the reference for all downstream either sub-assemblies or parts to be created from. So we go in, if we need to make a change, we simply go into that single part which has got sketches and geometry contained within inside of it, and we make a change to that part, go back to our assembly, and our assembly then passes down any changes that are necessary to downstream consumers of that information. Another methodology is multi-part or multi-level process. So in many respects, this is very similar to the previous process where we used a single part, but in this case we'll be using multiple parts, maybe to provide information about a unique area of the design or orientation. There might be a number of different requirements for that, but the reality is that by using this, we're essentially in many respects using a similar process. This often will be managed using a master subassembly, and that master subassembly will have master part files contained within inside of it. And then that master subassembly is inserted into the top level assembly that then drives all downstream features and parts or subassemblies and parts that have been created within inside of that top level assembly. Again, making changes to that master subassembly and the master parts contained within inside of it, then when updated through the top level assembly go on to impact all of the downstream users of that information. And then we have the distributed master, and the distributed master uses a single master part which comprises of sketches and geometry to define the final assembly. The master part is referenced in the various sub-assemblies and parts as needed. So as you can see here in the illustration, we have a master part, and this is then distributed amongst master sub-assemblies that then are then transferred through to the top level assembly. So the difference, from a single part to distributed master is that the subassemblies are referencing directly to this master part rather than referencing through the top level assembly. And these subassemblies then are transferred through to the top level assembly. And a middle out is really a combination of skeletal and bottom-up. It's using skeletal or top-down where appropriate, and then bottom-up where not appropriate. So we can take components that have been designed by themselves, insert those into an assembly or a sub-assembly that then is referencing in a top-down fashion the information contained within inside of those parts and sub-assemblies. So we've reached the halfway point of this overall presentation. Just a brief summary for what we've covered today in preparation for what we'll cover in the second half. In summary, we've looked at what are large assemblies. We've covered some of the terms and considerations. We've hopefully given you insight in some best practices in terms of common challenges that people encounter when working with large assemblies. We've given you some insight about project planning and file management. We've helped hopefully set up some of those preferences and work with some of the settings within inside of Inventor, given you some insight into the visualization effects and graphics of your system, as well as given you some insight into express mode and large assembly modeling workflows. As we highlighted earlier on, in part 2 of this webinar, we'll be looking at other areas like selection filters and component count and simplifying your components, as well as your system hardware and the impact that has on large assemblies, and how you can help increase the capacity of your system memory, as well as showing through a practical example a lot of the techniques that we've spoken about, not only today but also in that next session on a practical example. So just in wrapping up today's webinar, let's look at some of the more common questions you're most likely going to face, and that's going to include the likes of where can you get more information? Well, the Autodesk Knowledge Network is a good place to go. So if we've covered things, and even though I've tried to cover these topics in as much detail as I can, the reality is there's a lot more information that's still out there available to them. The Knowledge Network is a great place to go and find out further information relative to this. I would be Googling Inventor Large Assembly Management, which is the topic of this webinar, which is likely going to send you to the Autodesk Knowledge Network in a couple of different locations and cover some of the information that we've talked about today, plus some other stuff that we haven't had a chance to talk about. How can you contribute towards Inventor Updates? The Inventor Idea Station is a great place to go. So if you've got some ideas about working with large assemblies and you'd like to provide that feedback to the development team, then go to the Inventor Idea Station and put your idea up there. Vote for other people's ideas that they've already submitted, and hopefully they'll do the same for you as well. You can also participate in the beta program as well. The beta program is often looking at ways to improve the performance of Inventor and is releasing products early to beta testers to gather feedback from them on the use of those technologies. And how can you access the latest updates? There is significant advantage in particular around large assembly management in being up to date. Reason being is in some of the more recent releases, we've seen a number of enhancements in working with large assemblies. So what I would recommend you doing is, if you are encountering large assembly issues, performance issues, then potentially look to upgrade to 2018, or at least test out your designs on 2018 and compare them to the version that you're currently using to see whether the latest version has an impact on the performance of your systems. You can access this information from the Autodesk desktop app, which is available from your task. I think it's called your task pane, and opening it will show you what applications you've got installed and whether any updates are available for them. Also to install any of the newer releases if you're working on an older release. You can also access the updates and installers from your Autodesk account. So if you go to manage.autodesk.com, a lot of this information is available from there as well. Otherwise, thanks for attending today's webinar. We're almost spot on an hour. There's been a lot of information that we've covered, and likewise in the next session we're going to equally cover a lot of information. Hopefully many of you, if not all, will attend. Thanks for your time today. If you've got further questions about working with Inventor, whether it's large assembly related or to do with something else, feel free to reach out to your local Autodesk reseller. If you're trying to understand who they might be in our region, you can go use the autodesk.com/resellers webpage to find local resellers. You can also find more information about Inventor on the Autodesk website, autodesk.com/products/Inventor. And finally, if you've got some feedback or you've got some questions that you'd like me to answer directly, feel free to engage with me either via email or on LinkedIn. More than happy to help where I can. Otherwise, if you've got questions, feel free to put them in the panel. I often sit down in the minutes after the webinar is closed and answer and respond to those individually. So please feel free to do so on that. Otherwise, just a quick reminder, we are running the follow-up part of this webinar in 2 weeks' time on Friday the 9th of March at 12 p.m. This will be part 2, covering a lot of the topics that we spoke about earlier that we didn't quite get enough time to look at today. There is a short link there for you to be able to register for that. Don't be worried though, I believe the marketing team will be emailing you with a link that will direct you to that webinar if you didn't get a chance to see this first one. And hopefully that'll give you more than enough opportunity to be able to sign up for it. Otherwise, thank you for your time today. It is spot on 1 o'clock. Enjoy your afternoon. Today it's not quite so nice in Melbourne. Hopefully it is nice wherever you are around the country or around the world. Thanks for attending, and hopefully we'll see you next time. Bye for now.